Platinum, a very, very rare metal, has a density of 21.45. Now, density is mass over volume. Then assuming that the world production's been about 110 tons for each of the past 50 years, and negligible before that, which of the following has a comparable volume to that of the total amount of platinum ever produced? So we want to get the volume, and then we can rearrange this equation to get mass over density. So for the mass, right, now one thing we need to be really careful about is using the same units. So I've got grams, and I've got tons here. So for the mass, I've got 110 tons. I would times through by 1,000 to get the number of kilograms. And then I would times through by 1,000 again to get the number of grams. So that is the number of grams that the world has produced, but that's every year for each of the past 50 years. So I also have to times by 50. So that is the total amount of platinum ever produced, or that's our assumption anyway. And then we're going to divide through by 21.45. Okay, now I can estimate. I can say that this is roughly, I can make it 100 times 1,000 times 1,000 times 50 all over 20. So I might as well just do 100 divided by 20 and make it a 5 here, which gives me quite a big number. Do you know what? I'm just going to write, oh yeah, it's going to be 250 million, in fact. Now, this is our volume, but from the density, we can see it's in centimeters cubed. I decided to leave it at centimeters cubed and deal with it afterwards. You could have changed it into meters per meter cubed earlier on. I just quite like getting the volume and then converting it. Now, you have to be really careful here. Whilst 1 meter is 100 centimeters, when you start going up to area, for example, see the area, if you have 1 meter by 1 meter, would be 1 meter squared, but then it would be 100 times 100 centimeters squared. So 1 meter squared is 100 squared centimeters squared. You have to remember not just to divide through by 100, going from centimeters to meters squared, that is, but divide by 100 twice, or 100 squared. And then going to volume, extending it again, it's going to be 1 meter cubed is going to be 100 times 100 times 100 centimeters cubed. So what I'm saying is we have to divide our 250 million by 100 3 times. 100 times 100 times 100. Then that will be in meters cubed. And the reason I put it in meters cubed, I mean, we can see this seems like a big number, but is it really? Once we turn it into a meters cubed, is it really that big? We have to compare it with a shoebox, cupboard, and so on. So dividing through by 100, I can cross 2 zeros off, and again, we actually get 250 meters cubed. Now, try and visualize what 1 meter cubed is. A meter, you might be able to think about a meter ruler, or even if you took one big step, that would be about 1 meter. So then make it 1 meter in all of those directions. It's a reasonable amount of space, and for sure it's going to be bigger than a shoebox. Cupboards a bit vague, like you can get small cupboards and quite big walk-in cupboards even, I suppose. But it's not like it could be bigger than a meter cube, but it's not going to be as big as 250 of them. So at this point, it might be good to think about something that has a volume of 250 meter cubes. And actually, let's focus on a house. How big is a house? We'll kind of forget about the roof for the moment. Just imagine it as a cuboid. So ceilings are often about 2.5 meters. So maybe the house is about 5 meters in total. Of course, it could have 3 floors and so on, but it's just an idea. And then let's say that it's perhaps 8 meters in length. It's going to be a bit wider than 5 meters. Like a room could be even 4 meters or something. So maybe you have two rooms that's 4 meters each, and maybe it goes this way as well. Of course, houses vary in size. You can get small houses and very big houses. But if we look at the volume of this, well, 8 times 5 is 40, and 40 times 8 is 320. we're in the right ballpark. Okay, that is the main idea at the end of the day. So 320 meters cubed tallies quite nicely with the 250 that we have, and therefore it's going to be C, a house. If we think about Buckingham Palace, that's going to be a very, very big house, essentially, lots and lots of rooms. It's going to be much bigger than 250 meters cubed. And the Grand Canyon is even like much, much bigger again. So that's why we can rule those out.